I kind of don't want to coach
All right, let's go over this. Okay, listen up, everybody. So for those people who are not here, who are now having to watch this on video, this video that I'm recording right now, me going over the test, will be in the shared folder starting at 3:15 or 4 o'clock today. We'll call it 4 o'clock at the end of school. I'm not going to put it in the folder until then because Mrs. Lincoln and I still have people who need to take it. All right. And I need to make a different version of the test for those people anyway. So that means tonight you can go home. You could try doing it again. You can watch the video again. And it's going to be in the shared folder. It'll say test discussion. And tomorrow when you get to class, we'll have another test. Okay. This time all short answer. I can't take the time to make up tempting answer choices again. It takes a long time to do that. So it'll be short answer. Okay. So you got to show the work. If you memorize the steps instead of actually learning how to do the problem, to me, there's really no difference, right? It means you know how to do the problem if you memorize the steps. But really seek to understand, right? If you seek to understand, things will flow instead of having to memorize details, right? Okay. So here's the key. We're going to go over this. Multiple choice. First of all, put the capital letter of the correct answer in the blank. Some of y'all did not follow directions. Some of y'all did not use capital letters. And some of y'all did not put the correct answer there. Follow directions, okay? All right, let's go to the calculator. Cosecant of 1, 2, 3, 4, 5, 6, 7, 8, 9 pi. All right, so you're like, okay, I'm a robot. Cosecant of that angle, right? Robots don't think, do they? They process, but they don't think, okay? And sometimes they can process so well, it looks like they're thinking, but they're not. They're processing. So first of all, what mode should I be in here? Radian. So I'm going to go to mode. Oh, look, I was in degree. That was a close call. Look, radian. Boom. Now, you want to write on your paper what it is you're going to be typing in your calculator. So tomorrow, what I'm going to expect to see is 1 over sine of that, if that's what I give you. Okay. I may change these up a little bit. Okay. Because if I give you the exact same thing, you're just mimicking. So 1 over sine of that. It's going to be a short answer, so I need to see that. You don't have to write radian mode. Just be in radian mode. If you want to write it, that's fine. But this is what I need to see because that's what we're typing into the calculator. Okay, ready? Here we go. So you can go alpha trace, which is, or alpha y equals, sorry, numerator denominator. It's 1 divided by sine of 1, 2, 3. What was the number? I forgot. 4, 5, 6, 7, 8. Oh, thank you, Mr. Corpy, for making it such an easy number to remember. That is a huge angle, isn't it? And the calculator will give you negative 251,962.295. And you look at the answer choices and you're like, hey, that's answer choice B. Hey, I'm off to a great start, right? I punched something into the calculator. I got a number, and the number's an answer choice. Calculator might give this answer due to decimal overflow. We talked about that. Okay, I worked an example for you. That's not the right answer. Some people caught it because they thought about it. Others did not think. They were just processing, right? They were just, when I see this, I do that. And the calculator is you're the boss of the calculator. Who's the boss? You're the calculator. You are the boss, not the calculator. So you have to interpret its results. And we've seen several times this year that calculators don't always give you the truth. Sometimes they flat out lie. This is your calculator's way of trying to tell you the answer is negative infinity. Negative 251,000. That's not negative infinity calculator, but it thinks it is. Okay, so the answer is actually D and E. E. Now, why is it D and E? Well, a couple of people wrote this and mentioned it. This is an odd multiple of pi, right? It's all over 1, so it's a full integer multiple of pi, but it's an odd multiple of pi. Where do odd multiples of pi terminate? Yeah, negative 1, 0. If it's an even multiple of pi, it terminates at 0. If it's an odd multiple of pi, it terminates at negative 1, 0. Okay? So the calculator's angle is so big, it gets decimal overflow problem, and it can't quite work for you. If you were to type in just 1 over sine of, let's do this, second enter. If you were to make that angle a much smaller multiple of pi, Okay, let's just do that. I'll show you. Let's make it, if you were to make it like 1 over 9 pi, now your calculator is going to give you what? 5e to the 12th. What the heck is that? That's 5 times 10 to the 12th, right? That's a 5 with 12 zeros after it. That's like what? Trillion? 5 trillion. That's your calculator's way of saying positive infinity. Now, that's a little closer to positive infinity than negative 251,000 is closer to negative infinity. What if we make the angle even smaller? Like instead of 9 pi, what if we just say pi? All of those are coterminal with each other, right? And what do we know about coterminal angles? They have the exact same trig values. They have the exact same trig values. Coterminal angles have the same trig values. Now your calculator, because it's small, is going to recognize the division by zero error. Okay? But I give you big angles on purpose because giving you small angles is not fun. Okay? That would be for like regular pre-cal. This is honors pre-cal. So anyway, you know now that it's an odd multiple of pi. It terminates at negative 1, 0. Cosecant is the reciprocal of y. What's the reciprocal of 0? It's d and e. The reciprocal of 0 is d and e. Why? Because 0 is really equal to 0 over 1. And if you flip it, you get 1 over 0, which is some type of infinity. And of course, then that doesn't exist. So the answer is E. So tomorrow, gosh, tomorrow that might be an even multiple of pi. I don't know. Or it might be another odd multiple of pi. I don't know. It might be a secant. I don't know. I don't know. I haven't made it up yet. I have to actually kind of tweak the test tonight. But it's for y'all's benefit. We're reteaching. Tomorrow we're reassessing. Got it? Do your part, because I'm going to do my part. Do your part. Care, think, and develop SISU. Okay? The strength of the team is each individual member. The strength of each member is the team. And that's us. Right, Keen? Yes, sir. Yep. Good. Pretty handy having that written on the back of his shirt. Yeah. Y'all just thought I was wise and made that up. All right. Question on letter 1. It's a number, sir. Yeah, I know. Question on number 1. Okay, number 2. What is the reference angle for 6703 pi 51st? Oh. We do this all the time, right? Here's the way I taught you to do it. We got to first figure out the coterminal angle. Where does it live between 0 and 360, or in this case, 0 and 2 pi? So remember, the way we do that is we take our numerator, the coefficient of pi, which is 6703, 6703, and we divide it by twice the denominator, which is 102. That gives you the number of rotations. We don't type in 0.715686727. We subtract the full rotations to preserve the decimal, and notice more appear, and then we always remultiply by the number we just divided by. Boom. That's 73. That is your new coefficient of pi 51st. All right, so let's process that. Is that an answer choice? It's answer choice C. I did something, I got a number, it's there, that must be it, right? That's for people who do not think, right? So we know then that those two angles are coterminal. We could say that 6703 pi 51st is coterminal with 73 pi 51st. And thank you to those who are actually starting to use the coterminal symbol. Pretty soon it'll sweep the nation, okay? They're coterminal. So remember, we need to figure out now where 73 pi 51st lives. So we come down here and we break up the unit circle. Remember, this is always pi. Pi is always over here. So we're counting by 51st. Okay, so that's 51 pi 51st. What's half of 51? 25.5. So now you have your quarter cycle counting interval. 25 and a half plus 25 and a half is 51, plus 25 and a half is 76.5, plus another one is going to be 102, but that's all we need. So where does 73 live? It lives between 51 and 76.5. See that? So now I'm going to draw that terminal ray in this quadrant. Now, the reference angle, remember, is always the positive acute angle between the terminal ray and the x-axis. That's this right here. So how far is it from 51 to 73? Well, 73 minus 51 is 22. And there's your reference angle, 22. Now notice all the work that I'm showing. Tomorrow on the retest, I'm going to expect you to show everything that I just wrote, okay? There's a higher burden of proof now, okay? Higher burden of proof. So I do want to see this. I want to see your calculator notations. All right, so notice I wrote it down. That divided by that is that many rotations. I didn't just then take this number and put minus equals minus 65 there. I actually came down to the next row and did that minus 65 is that. And then I came down to the next row and I said that times 102 is that. And then I said, so that angle is coterminal with that. This indicates your method. And tomorrow I want to see it, okay? I gave you all the chance already to do it without having to show me. Didn't work out. Didn't work out. So now I want to see it. And then accompanying with a graph like this. And then now we can see this. And then look, here's the work. So, or ergo, or thus, therefore, consequently, whatever you want to say, this minus this equals that. And notice it's labeled as theta ref. Okay? Y'all can do that. By the way, this key I will also post tonight. Okay? So this key will be posted, and the video of me going over this very key with y'all, first period class, waking up with math, right? Crunch wrap supreme, right? It's got a full hash brown in it and got some math in there. Math is like the salsa you sprinkle on top. It's good breakfast, right? Right, Mal? Was that good? All right, I'm going to try it tomorrow. Hey, Wendy's has breakfast now. Did you see that? There's a commercial of Wendy's breakfast. So anyway, I'm going to try and stay on task. Okay. Any questions on part 2? All right. Letter 3, 4, negative 998877 degrees. Find the coterminal angle beta. So I've named the coterminal angle beta such that, and what the heck does this mean? This means that I want the coterminal angle to fall between 0 degrees and 360, right? That means within one positive rotation. Within one positive rotation. That's in our wheelhouse, right? That's where we're comfortable. That's the unit circle. But we're going to be in degrees, okay? So again, this was like one of the first types of problems that we did. We take, and again, tomorrow, this is what I would expect to see. I'm not going to go to the calculator now because I have all the work written out. I think y'all can get the calculator commands pretty easily. So I'm just going to write it down. All right? So you take your big angle and you do what? You divide it by 360. And that gives you this number right here. What are the units of that number? Rotations. Now, you don't just put plus 277 here because then you're going to be lying. Those would not actually equal. So now you take that number, go down to the next row. That number plus the full rotations equals that fraction of a rotation. The dot, dot, dot means that we're still using the live answer. Okay? And then I go down to the next row. That number times 360, that's negative 237. Now, negative 237 is indeed coterminal with this negative angle here. But is that the one I want? No. So all I do is I drop the negative sign, right? And choose answer B. That's not how it works, right? Remember, we have to add one more full rotation to it. So now negative 237 plus 360, one more full rotation, gives you 123 degrees. So all of those angles are coterminal with each other. Negative 998877, negative 237, and 123. They're all coterminal with each other. Okay? Tomorrow, this is the work I would expect to see. Got it? I want to see your calculations tomorrow. What is it you're typing into the calculator? I need to see it. Okay? And here's what I mean, don't do this, because this is lazy math. If you just went that divided by 360 equals negative 277, and you do this, hang on. You say, okay, now to that I need to add the 2774, and then that equals 0.658. All right, you're telling me what you're doing, but guess what you've also done? You're a liar. And you can sue me for libel if I call you a liar. You're not going to win because you know what? You are lying. Right? I'm going to call you a liar because that's what you're doing. Why are you lying? Because you're saying this divided by 360 equals 0.658, does it? No. When you go from one line to the next, one dot to the next, you're doing something now you're doing something different. You can't just string them together with equal signs. When you say that two things are equal to each other, you better be darn sure that they are, right? So this number here does not equal that number. So don't do that, okay? That is bad math. So what do we do instead? You don't call each other names, but then don't give me an occasion to call you a name, okay? You take this number, you go down to the next row, and you say that number plus equals this. Then that number on the next row times 360 equals that. So that number plus 360 equals that. Yes, Keen? That works too. Yeah, if you know how to do that, you can go straight to the other one. Yes, Keen, that's good. Good, good, good. I mentioned that I think once. I never actually showed that to you. I mentioned it once. If that makes more sense to you, like it does to Keen, that's fine. As long as you're showing me exactly what it is you're typing into the calculator, what exactly it is you're doing. I need to see your thoughts, right? Okay, good. Letter 4. Cotangent of negative 2 pi thirds. Oh, we got this. This is straight up on the calculator, right? Straight up calculator. So what would this be? Well, we don't have a cotangent button, so that's the same as 1 over tangent of negative 2 pi thirds, right? So you could do that, right? And now if you go to the calculator, calculator, we should be in radian mode. Check, we're in radian mode. And we go alpha y equals, boom, 1 divided by tangent of negative 2 pi. And then we can use the diagonal bar here, divided by 3. Big bucks, no whammies, 0.577. Oh, yeah, let's see if that's an answer choice. What the? None of those are 0.577. But I know it's a positive number, so it's got to be either what? 3 or D. So here's what you could do. You could just type it in, right? Well, what is answer choice D? It's the square root of 3, click to the right, divided by 3. Please be 0.577. Oh, darn, I typed in I. Woe is me. Okay? And now you call me up. Mr. Corbin, my calculator, I don't know what I'm doing. Hey, there it is. So that's one way to take the test, right? It's called back. You compare your answers to the exact. That's one way to do it. And if you decide to do it like that tomorrow, that's fine. That's fine. I just need to see 1 over tangent, and I need to see the decimal version here, and you're done. Okay? But the problem is tomorrow when I ask you this, I'm going to ask for the simplified exact value. Simplified exact value. Well, that's no big deal, right? Now you just go to your calculator and you hit math, enter, enter, right? That'll convert it back to a fraction for me, right? Math, enter, enter. What the? Why will it not convert it back to a fraction for you? Square root of 3. It's irrational. So tomorrow doing it on your calculator and getting a decimal is not going to really be helpful because I'm going to be looking for the exact answer. So what's the other way to do it? Hey, it's blah, blah, blah pi thirds. That's coterminal with something on the unit circle. Yes, yes? Yes, yes. So you can do one of two things. You can either add 2 pi to it, add a full rotation to it. 2 pi is the same as 6 pi thirds, right? So negative 2 pi thirds is coterminal with 4 pi thirds. Now notice how I wrote that. I kept the cotangent in front. This is equal to this is equal to this. So even though this angle is not equal to this angle, their cotangents are equal, right? Because coterminal angles have the same trig functions. Now, where is 4 pi thirds? It's over there in quadrant 3. What's the ordered pair? Negative a half, negative square root of 3 halves. Sweet. What did you ask for? Cotangent? Okay, that's x over y. And remember, your denominators are going to divide out, so you don't need to worry about the 2. So it's negative 1 over the negative square root of 3. Okay, and you look to see if there's an answer choice, and like, dang, that's not there. So then you're like, okay, a negative divided by a negative is a positive. So then you look for 1 over the square root of 3, and that's not there. And then you're like, criminy, I guess he rationalized it. Multiply by square root of 3 over square root of 3. Okay, times the square root of 3 over square root of 3. And you do get square root of 3 thirds. So that's the way to do it. So you should be able to recognize a unit circle angle or coterminal with just by looking at the angle, because it's going to be blah, blah, blah pi fourths, or blah, blah, blah pi sixths, or blah, blah, blah pi thirds, okay? And all you got to do is figure out where it lives. Now, you could have actually just used negative 2 pi thirds, right? Because negative 2 pi thirds rotates clockwise by that amount. That's negative 2 pi thirds, right? It's just short of a rotation of pi, which is halfway around. And then you could have said, oh, that lands at the same spot as 4 pi thirds, okay? They're coterminal with each other. Coterminal. There's the symbol. I love it. I love it. Okay? There you go, YouTube. There you go, World Wide Web. Use it for free. Okay. Any questions on number 4? All right, number 5. So I was sitting at home and I was like, I turned on my Spectrum app because I don't usually use the app. I usually use the box, but I do have Spectrum, so I have a DVR recorder, which is a cable box. But I also sometimes watch on the app. Um, I don't know why, but I went to the app and it was set. It came on as one of my high number ESPN channels. It was like ESPN 4 or something like that, news, right? Whatever. It was on there, and then what showed up was a cricket game. And I was like, wow, that looks cool. And then I started thinking, hey, what else happens on a big field? Track and field. So then I was thinking maybe I can write a problem about a discus. And I was like, no, 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 because that's a little bit different. So javelin. I remember watching a video a long time ago of a guy throwing a javelin like this. And it came right here to one of the judges, and guess what? Boom, the javelin impaled him. And I'm like, God, that I remember that. You can probably, not now, but later you can probably Google it. Javelin judge gets impaled by javelin. It'll show up. It's there. He survived, by the way. And I was like, that's cool. So the javelin field is a sector of a circle. Okay. So I wrote a question about a javelin. And I actually Googled dimensions of a javelin field. So these numbers are hot off the press. This is a true story, guys. True story. The javelin throw is a common field event. If the landing area is in the shape of a sector of a circle, and I gave you this little icon here, although you didn't get it in color, with a 29-degree central angle. Again, true story. Approximately how much area in square meters does the javelin have to land in if the radius of the landing field is 90 meters? So this last white line right here is the 90-meter mark. You can kind of see this is 80, 85, and this would be 90. And it looks like most of the javelins fall between 85 and 90. And I don't know. I guess you get bonus points if you hit one of the judges, right? So anyway, true story. So here's what I did. I know that I need to convert the angle to radians. And you can do it in the problem or you can do it off to the side. So 29 over 1, that's degrees, multiplied by pi over 180. That way your degrees divide out, right? So if you do 29 divided by 180, look what happens. 29 divided by 180. You're going to get a decimal. And then you hit math, enter, enter. Math, enter, enter. Come on in, math. And it's the same, 29 180th. It doesn't simplify. 29 is a prime number. So guess what the angle is? It's 29 pi 80ths. So now you go to your area of a circle, sector of a circle. It's 1/2 r squared theta. 1/2 r squared theta. So in square meters, we get a half is a half. The radius is 90. I gave that to you. Squared times and 29 pi 180ths. So you could have just done times 29 degrees times pi over 180 degrees. You can actually convert it in the problem. If you type that in, okay, just like you see with the pi button, you get 2049.889 meters squared. The closest answer to that, if you round to the nearest whole meter squared, is 2050. Okay, now look how I did that. Look how I did that. Tomorrow, this is exactly what you're going to write. I have the formula. I'm plugging in. I see the answer to 3 decimals with units, and then a squiggles to the nearest whole meter squared, 2050. Okay? Now, if you forgot to square it, the answer was there. If you forgot to convert the angle and use 29, the answer was there. So all those common mistakes were answer choices. You're welcome. So there you go. If you want to be a javelin thrower, you say, man, I have pretty good odds of landing in the field. There's over 2,000 square meters of places I could throw. Yeah.
What I did, I divided 29 by 360, and then I get that decimal and I multiplied it by 590 squared. Is that okay?
You did 29 divided by 360. Okay, so you use kind of like proportions. Yeah, that's fine. As long as tomorrow, Keen, when you do that, you show me exactly your calculations. I want to see how you're getting the answer. Okay, and it's not this. You don't say show my work. Here's where I'm going to show my work. How I got my answer. I looked at neighbor's paper. Okay, and I got 2050 meters squared, right? So show me exactly how you're getting your answer. I would appreciate the honesty here, right? If you did that, I'd be like, okay, I'm sorry, you're going to get a 0 on the test, but I'll give you 5 points for your honesty after the fact. So I'll give you a 5 on the test, okay? Honesty is worth something, okay? Yes?
When we get to like these dimensional
Uh-huh.
We don't really have to like fill it all out because I kind of just punch numbers in.
I want to see what you're punching in. Okay? If you have a different way of doing it, I want to see what you're punching in. I want to see your thoughts. We're treating these tomorrow like free response questions. Okay? And why are math teachers so keen on students showing their work? Yeah, it's a safeguard against cheating, right? Because if someone is trying to copy your work from over here, they're drawing instead of writing. Yes, they're like, that looks like he's got a little curve there. It might be a T. So I'm just going to kind of draw something that looks kind of like maybe like a T. He's got a line going through it at a top, kind of at a steep angle. So maybe that's a T, right? You're drawing. You're not thinking. You're copying. So showing work is a safeguard against copying. That's one reason. Exactly. We want to be able to spot check where it went wrong. Okay, did you use the wrong formula? Were you not in radians? Did you round incorrectly? Excellent, you got great answers, Peyton. That's Peyton Nelson, by the way. Yeah, YouTube. She's a former rattler. Much prefers to be a unicorn. The other reason is because it helps you think. You are learning to communicate. You're communicating your results. And that is a life skill, whether you're communicating math, you're communicating the emotions and the feelings you have in your heart, or you're talking to a boss or a group of people, you're learning how to effectively communicate. All right? That's probably the biggest reason. Okay. Letter 6. Talk about communicating. He doesn't know his numbers from his letters. Here's your twos clues problems. Secant of alpha is -9, -11/5, and cotangent of the angle is positive. So, first of all, secant of the angle alpha is a negative number. Where is secant negative? Whenever cosine is negative, which is whenever x is negative. Secant is r over x. R is always positive. So x is negative to the left of the y-axis. That puts us in these two quadrants. Cotangent is positive. Cotangent's x over y. So cotangent's positive when x and y are both positive, quadrant 1, or when x and y are both negative, quadrant 3. Where's the overlapping quadrant? Quadrant 3. So now I draw my terminal ray into quadrant 3 and I label it as alpha. Now, you don't even have to drop a perp here and find all three sides. Because remember, all you need is one ratio for the calculator. And now you look at the secant ratio. If I have the secant ratio, guess what ratio I have for free? Not the sine ratio. The cosine ratio. Because they are reciprocals of each other. So if secant of that angle is -11/5, then the cosine of that angle must be -5/11. Yay. So now I'm going to solve for alpha by taking the inverse cosine of both sides. This is what I need to see tomorrow. If I don't see that, you're not going to get credit, okay? Alpha equals inverse cosine of -5/11, or theta equals inverse sine. Now, what mode should we be in? Well, look at your answer choices. What are they all in? Degrees. So in degrees, when you take the inverse cosine of -5/11, it gives you -117.035. Where does -1 or +117.035 live? Quadrant 2. Is that where we want it? No. But what do we know? That's where secant is negative. So what do we know about the calculator's answer and our answer? They have the same what? Yeah, they have the same reference angle. So how can you find the reference angle? Well, I'll take my calculator's answer, which is in quadrant 2, and I'll do 180 minus that, and now I get my reference angle, 62.964. What was one of the answer choices? 62.964. Dang, Mr. Corpy, you have such seductive answers. Is that the one we want? Nope. Okay, so now we use the our reference angle from the calculator's answer, and we go to our terminal ray. We have to go all the way around the reference angle amount past 180. So what's 180 plus our reference angle? Yeah, on your calculator, you could just hit plus 180, and you get 242.964. All right, let me show you. It's right there. No, I didn't do it. Okay, you can do it on the calculator tomorrow. But here's what I want to see tomorrow when we retest. All of this work, okay? Let's go through it again. We know what quadrant it's in, right? Quadrant 3. If I give you the secant ratio, then I also give you the cosine ratio. You solve for alpha by taking the inverse cosine on both sides. I wrote in degrees. Is that helpful? Like if you wrote that tomorrow on the test, would I be happy? When in doubt, do we leave it out or add it? On a short answer or free response. Add it. We don't leave it out. When in doubt, don't leave it out. Because remember, you're communicating how you're getting your answer. So this is a nice courtesy. It's not needed, but this for sure is. Alpha is 117. That's not the one we want. So the reference angle is 180 minus that. And there it is. And notice I labeled it subscript. Now you go back to your picture and you say, oh, I got to go 180 plus that. So you show me that you're doing that. 180 plus the reference angle or 180 plus 62. And we get 242.964. And is that an answer choice? No. Darn it. But we know that's the right answer. So what do we do? What do we do? We panic? Yeah, we don't panic. Very good. We look to see what the answer choices are. You can do process of elimination. I know it's not going to be that because that is the reference angle. I know it's not going to be A because that's in quadrant 2. That's the one the calculator gave me. So it's got to either be this one, or this one. And notice all of those angles are bigger than 360 in magnitude, yes? So the answer that we want must be what to 242? Coterminal. Good. So look what I wrote here. 242 is not an answer choice. So the angle alpha must be, like y'all just said, coterminal with it. How do we generate coterminal angles in degrees? We add or subtract multiples of what? 360. So look what I did here. I took my angle 242 and I just started subtracting 360. Subtracting 360. And so when you do that, when you do it once, you get negative 117. You do it again, you get negative 477. Are either one of these two answer choices? No. And you can keep going if you want. So then you go back to your angle, and now you're adding 360. So I added it a couple of times, and I got these two angles. All of these angles on that row are what with each other? Coterminal. You know what? I think I want to do something now. I put commas between them, but what would be a better symbol to put between them? Our little coterminal symbol. So let's do this. We'll make it, you could do little perfect circles, can't you? There we go. And then we'll snap two horizontal lines through it. Does that look okay to y'all? We should adjust it. There we go. Oh. There we go. I know they're not the same, but it looks pretty good. So there's our new symbol. We'll copy and we'll paste it. There it is. Paste it. There's not enough room in between there, but you get the idea. Those are all coterminal with each other. And of course, one of those hopefully is an answer choice. Which one? The 602.964. Okay. Have we ever done that in class where we're just adding 360 or subtract? Yeah. That was like one of the first things we did, right? You weren't here for that, but you've already done that, right? Yeah. Good. All right. And then look, whoop, there it is. Whoop, there it is. It's a great tag team song, right? It's on my hallway playlist. Okay. Any comments or questions on that? Yes. Maybe if it's the same angle, I might change it up a little bit, but the idea will be the same, right? The idea will be the same. So what would I expect you to show me? Once you find 242, I might tell you to give me the answer. I might give you this. I might say, give me an answer alpha such that alpha is between, I don't know, negative 720 degrees and negative 360 degrees. That would tell you where I want the angle to live, right? So once you find your positive angle, if we wanted it to live in there, what would we do? Subtract 360 until we get one that lives between those two, okay? So that was a good question. If because it's short answer, I can't really ask which of the following could it be, right? Because now you're like, there's no answer choices, sir. So I have to rewrite it as a short answer problem. Any other questions? Okay, good. Let's move on to example 7. Sine is 7/25, and the angle whose sine is that lives in quadrant what? Between 0 and pi halves, quadrant 1. It is like 1. Okay? So you draw in quadrant 1, you use the Pythagorean theorem. Okay? Pythagorean theorem. X squared plus y squared equals r squared. Okay? It comes out to be, you have your calculator, plus or minus 24, but because we're in quadrant 1, it's positive 24. And now I ask you, what's the secant? So this was r over x. That's 25 over 24. That's the answer choice. That was probably the easiest one on the test. That was probably the easiest one on the test. Is that the one you missed?
Yeah.
Oh gosh. Oh my gosh.
I don't know how.
I don't know either.
Something like cosine.
Yeah.
So, whenever you're doing the Pythagorean theorem,
Yes,
you
ma'am.
have to put the plus and minus since you know R is going to be.
If you know it's already going to be positive, you could skip the plus or minus here. Yeah. But by putting plus or minus there and then saying so, you're telling me more information. You're telling me that you've considered both plus and minus, and you have consciously and deliberately chosen the positive one. If you don't put the plus or minus there, then I might think that you were careless and forgot to do plus or minus and just got lucky. Does that make sense? So it's better to show the plus or minus and then make a deliberate decision. But would I take off if you just said x equals? No. But have this thing live in quadrant 2, and you have x equals positive 24. Now we got a problem. Okay? All right. Letter 8. A school bus full of unicorns. Yeah, yeah. Peyton and Landon are on board now, right? We're all heading down the road to a math competition on I-35. If the yellow dog has wheels of 42 inches in diameter, and I actually looked that up on Google too, right? I wanted to give you accurate numbers. 42-inch wheels, and they spin at 384 RPMs. How fast is the bus cruising down the highway? Well, this is one of those stoichiometric problems. You start with the variable quantity, which is the rotations. 384, you're going to write it as revs per 1 minute. All right, now we need to get from revolutions per minute to miles per hour. So I did the time first, minutes in the bottom, minutes in the top. So 60 minutes in an hour, minutes divide out. So now we have hours. So now we need to get from revolutions to what? Miles. So here we go. Revolutions in the top, so I put it in the bottom. 1 revolution is the circumference, right? This is the circumference. Circumference equals pi d. So it's 42 pi inches. Now I need to get from inches to miles. So inches in the top, inches in the bottom. 12 inches is a foot. And then the inches divide out. And of course, you know that there is 5280 feet in the mile. So you type all that into your calculator and you get 47.9806, which is approximately 48. And I tried to come up with a number that I thought was really feasible, right? Is that about how fast those yellow dogs go on the highway? 48 miles. All the cars are passing by saying, man, what school are they from? It sucks to be going so slow, right? And the school bus driver's like, safety first, right? And you want that person behind the wheel, right? Safety first. 48 miles per hour in a 70. That's almost a liability, right? Drive at least the speed limit, otherwise you're... Sometimes they post minimum speed limits. Okay, and then number 9. I thought, how can I write a question that's like the one we did in class, but how can I use a planet that is a fun planet, the most fun planet? So I said, man, this test is probably already going to kick their butt. Let's use Uranus, right? So Uranus travels in a nearly circular orbit around the sun. You can just imagine, really, my anus does? Really? Yeah, right? So little comic relief here on number 9. Uranus travels in a circular path. It's 1.8 billion miles away from the sun. Again, true story. I Googled it, right? I don't use Bing. If it makes it around the sun once every 84 Earth years, that's its orbit. Bless you. How fast is Uranus moving through space? Okay. Well, I drew a little picture, right? And I said, there's Uranus right there. Okay. There's Uranus. The radius is 1.8 billion miles. So V equals R omega. V equals R omega. 1.8 million. Okay. And then I do 1 rotation per 84 years. That's the angular velocity. Radius times 1 rotation per 84 years. I now convert from rotations to radians. 1 rotation on the bottom, 2 pi rads in the top. And then I convert from miles to, well, I wanted miles. I have miles. So I convert, what did I do? 2 pi radians to 1 rotation. 1 year is 365 days, and then 1 day is 24 hours. Okay, so that gets me miles per hour. And when I multiply all that out, I get 15,000 approximately. Okay, and notice what I did here, 15.369.827, and then squiggles. Yes?
So tomorrow on the response, do you want us with the like
The 3 decimal approximation? I'll probably add there, give a 3 decimal approximation. All right, so you could just list this one, 15369.827.
Dan, do you
Yeah.
want us with the
No, then you don't, no, you wouldn't. When it's a multiple choice, you're trying to match it up to one of the answer choices. So you know you have to kind of do the approximation. All right, so that's all we have time to record because the class is going to end. So what's going to happen is I am going to have to record me going over the free response during my conference period today. And then now it's your job to do what tonight? Go watch the video. Okay, I'll try and do it quickly. I'll try and make it like 10 minutes so that you can get through it quickly, but look for it in the shared folder. This one will be in the shared folder. It'll be multiple choice discussion. And then today at 4 o'clock, you should look for free response discussion. We're retesting tomorrow. Bring your test back with you. Do not lose it. And have a great day.